Assalamualaikum warahmatullahi wabarakatuh. My name is SITI Hanisah binti Nur AZMI with student number 2019-287-494. In this video, I will be explaining experiment F1, hydrostatic force on plane surface. First, the objective of this experiment. The first objective of this experiment is to determine experimentally the magnitude of the force of pressure, hydrostatic force, and its point of action, center of pressure, on both submerged, partially submerged plane surface. The second objective is to compare and analyze the experimental results with the theoretical values. Next, I will be explaining the apparatus that we use in this experiment and the part by part of the apparatus. So the apparatus that we use for this experiment is hydrostatic pressure apparatus. So the first one is counterweight, the second one is tank, the third one is drain valve, the fourth one is adjustable feet. The fifth part is the balance arm. The sixth part is the quadrant. The seventh part is the balance pointer. The eighth part is the balance band. The ninth part is weight. The 10th part is the depth of immersion scale. The 11th part is spirit level. Next is the procedure of this experiment. The first step is place the hydrostatic pressure apparatus on the top of the bench. Next, make sure that the apparatus is installed properly. After that, level the apparatus using the adjustable feet facilitated by the spirit level attached. Step number 4, adjust the counterweight to level the balance arm to a horizontal position. The step number 5, make sure the drain valve V16 is closed and slowly add water into the tank until the surface just touches the quadrant base, thus establishing a datum level corresponding to 0 at the level scale. Next, place a 50 gram weight on the balance band and slowly add water into the tank until the balance arm is again horizontal. The step number 7, record the mass of weight M and depth of immersion D in the experimental datasheet. Next, repeat step number 6 and 7 with numbers of weight until the tank is full of water. The step number 7, drain off the water after the experiment is complete by opening valve 16. The safety that can be important in this experiment is during filling in the water and drain off the water process, make sure to do it slowly and carefully to avoid the water from spilling on the floor because it can lead to an accident such as falling due to wet, slippery floor. Okay, for this part, I will do the calculation and plot the graph for. In this table, I already used the set data number 2 that I have taken it from the future. So mass mass depth of emission full or partial. This one is already, the data for this is already in the set data number 2. So we just need to calculate the resultant hydrostatic force, second moment experimental, second moment theory, and error. For the table, I already do it. We just fill in the blank by doing the calculation and plot the graph. From here, resultant hydrostatic force, we need to use the formula rho G BD squared over 2. So okay, for the second moment experimental, the formula that we will use here is mgl over f. So okay, from here, the second moment theory, we need to use the formula h minus d over 3. So d that we will use here, the depth of emission. So from here, h equal to h okay, enough. And then for the error, we will use the formula E minus t over t times 100%. E is experimental, t is theory. So So from here, we will do the the graph, which is resultant hydrostatic force against the second moment of experimental and second moment of theory. So from here, we insert the select data at the x value, and then this one is yeah. Okay, data, okay, the okay. From here, we change the
This one is the result. Hydrostatic. And this one is the second moment. And then after that, it is the which is
The next part of this experiment is conclusion. So for the conclusion in this experiment, in conclusion, this hydrostatic force on plane surface experiment has achieved its objective, which is to determine experimentally the magnitude of the force of pressure, hydrostatic force, on both submerged, partially submerged plane surfaces, also to compare and analyze the experimental result with the theoretical values. Furthermore, all the data needed from the experiment, such as resultant hydrostatic force F and second moment for both experimental and theoretical values, are obtained from the experiment. Based on the data obtained, a set of graph which is resultant hydrostatic force F against the second moment of both experimental and theoretical values is determined. Overall, the experiment can be considered as a success. The next part for the experiment is recommendation of the experiment. There is 3 recommendations that I can recommend for this experiment. So first one is make sure to understand and follow each step of the experiment procedure to avoid allowing any error happen during the experiment. The second one is make sure that the eyes are parallel with the scale during taking the reading of the experiment result so that parallax error can be avoided. The third one is use the right concept and formula to calculate the data for the experiment to avoid making mistakes during the calculation process. Last but not least, the application of this experiment. There is 2 applications that we can see in this application of the experiment. First, the first application of this experiment is when the mass of water that a submarine or any other boat displays pushed out of the way equals the mass of the boat it can float. This displaced water produces an upward force known as buoyancy. Buoyancy works in the opposite direction of gravity, which would cause the ship to sink. A typical boat's buoyancy cannot be controlled or changed, but a submarine can. So for the application number 1, the example that we can closely see is the submarine and also the floating dry dock. Its application is almost the same with the submarine. And when talking about buoyancy, it's also relate to Archimedes' principle. So the next application, which is application number 2 of this application of the experiment, is the capacity and position of the water pressure force operating on the water control structures such as dams, levees, and gates are critical to their structural design. Many aspects of hydraulic equipment require the design of hydrostatic force and its course of action. For this application number 2, the closer example that we can see is the Hoover Dam, which is relate to the capacity and position of the water pressure force operating. That's all from me. Thank you.